Hi viewers, welcome to our solution. Today we are going to see about the battery driven electric vehicle with a regenerative braking operation concept in MATLAB. This is a simulation model we are created for a battery powered electric vehicle. This model consists of a battery and then bidirectional DC-DC converter and then DC motor. And this battery converter going to be controlled by means of speed control method. Here we are measuring the speed of the DC motor. This DC motor speed will be compared with the reference speed. Then it going to be processed via PID controller. After PID controller, the PID controller will be generate the duty cycle. The duty cycle going to be processed via this PWM generator. So this PWM generator will be generate the pulse. So this pulse going to be used for drive this two MOSFET. So it's going to be drive that to MOSFET, not to supply the power from the battery to a DC motor during motoring operation. During braking, some energy will be reversed, some power will be reversed in the DC motor that going to be stored in the battery. During that time, the current direction going to be in the reverse direction. That will happen when we are going to reduce the speed. For example, consider you drive the vehicle, we are going to increase the accelerator. It going to be the speed of the electric vehicle going to be increase, and you are going to maintain around 80 km per hour. During you are going to apply sudden brake in the electric vehicle, what will be happen that there will be a torque in the negative direction that need to be stored in the battery. That can be possible by means of this bidirectional DC-DC converter arrangement. When we are applying the brake, whatever energy stored in that machine, that going to be returned back to that battery via this DC-DC converter. So during that time, during speed increasing condition, right, battery will be supply the power to the this DC motor. During applying braking, right, whatever energy is stored because of that negative electromagnetic torque, that going to be stored in the battery. So during that time, current direction only going to be changed. And also when you have to look from this side, it will be act as a boost converter. When you are going to look this direction, it will be act as a boost converter. So we can call this converter arrangement nothing but the bidirectional buck boost converter arrangement. And I'm going to explain here. Here we have the battery voltage we are consider as 60 and rated capacity is 400 Ah. The battery SOC is 50%. So this is a machine here we are having. So here we are using 240 volt machine with rated speed of 1750 rpm and 300 volt DC motor, and rated power is 5 HP. And then here we are applying load torque is 10 Newton meter, and then here we have reference speed condition. So initially I'm going to operate the motor at a constant speed. I'm not changing any speed in this machine. So I'm going to show the result of the battery voltage, current and SOC, and then I'm going to show the result of the speed of the electric vehicle or the speed of the machine, electric machine or DC motor, armature current and the electromagnetic torque without changing any speed reference. And also I'm going to show that tracking of speed also, and then this is voltage across that machine. First I'm going to simulate this one, and then we will check the results. Now we can see here reference speed. Here we are fixed at 120, so it will be tracked that reference speed after 1.5 seconds. This voltage across that DC machine is around 150 volt. And then here you can see here this is the battery voltage and then battery current and the battery SOC. The battery SOC is keep on decreasing because of battery supplying power to the electric motor. And then is the current is taken from the battery is around 27.5 amps, and here you can the speed of the machine is maintained at 120 radian per second, and then the torque of the machine is maintained at 10 Newton meter, because low torque we are maintained fixed at 10 Newton meter. Here you can see that it maintained at around 11 Newton meter, and then current of the machine is around 11 amps. This is for forward motoring condition or motoring operation. Now I am going to check the condition. That means we are going to apply the brake here in order to create the regeneration concept. So first I am going to maintain the reference speed equal to 120 radian per second. After some seconds I am going to change the speed from 120 radian per second to around 50 radian per second, and then we have to check the changes in the system. how the machine will be react when we are going to apply the brake. That means we are reducing the speed of the machine. So during that time, how the machine will be act, and then how the energy will be transferred from that machine into that battery, like the regeneration concept. Here I'm going to make that the reference speed after 2 seconds. Initially we will be run at 120 rating per second, and then after that it will be changed to 50 rating per second. And then I'm going to make small that means reducing the speed of the machine reference speed from 120 to 50 at 2 seconds. So I'm going to take another 0.05 seconds. That means that the regeneration will be, you can see, slightly within a second. So that's why I'm making the time. So I'm going to simulate this same model, and then I'm going to explain the detail with how that regeneration happen in the system while we are reducing the speed. Now we can see here these changes happen when that speed, that means here you consider the speed reference is changed here, but because of change in reference speed, the speed is reducing here. In this portion you can see, right, this is reference speed, the blue color is actual speed. Because of change in reference speed, the actual speed of the machine also tried to reduce. So you can see that reduction of that speed. So now you can see that because of reduction of that speed command, the voltage across that motor also going to be changed. And also here you can see that change in the speed is reducing. And then here you can see that variation of like here you can easily understand that. Now you can see that the current of the DC machine or DC motor is comes to minus 20 amps. Here when you are going to apply the brake, that what happened, that it will be going to act as a generator. That machine DC machine is going to act as generator. That's why the current is changed from 11 amps to minus 20 amps is comes to here. And also you can see the electromagnetic torque of the machine, which changed from 11 Newton meter to minus 20 Newton meter. This is known as a regeneration. Because of regeneration, how that energy will be back to that battery. Here you can see here, I'm going to zoom this area. We will see that detail. Now we can see here that battery current. So this battery current is changed from 27.5 amps to around minus 18 amps. This is because of this regeneration. The whatever energy generated during regenerative braking, that will be sent to that battery. And also I'm going to expand that. Yes, you will see that clear here. Now we can see that the SOC of the battery is increasing because of that regeneration energy. Because of braking, that the SOC of the battery also going to be increasing. And also I need to check that voltage also. Because of applying voltage, we need to check the voltage, whether voltage increasing. Here you can see that the voltage of the battery also increasing because of generation, because of that regenerative braking. This has happened when that will regenerative braking concept applied in the electric vehicle. Whenever you are going to apply the brake, that during that brake, whatever energy in that machine, that will be returned back to that battery. This is known as regenerative operation of the electric vehicle. So this is battery driven electric vehicle with the regeneration concept. Thanks for watching our videos. Kindly subscribe to channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.